Hello everyone, so I'm gonna solve this problem binary search tree to greater sum tree. So what is happening here is one binary search tree is given to us and we have to replace the every key value with the sum of all the values which are greater than this. So take an example of this question itself. So what is happening here, you can see here, this is 4, right? The key value is 4 here, but this value has to replace all the sum of the greater value. So as we know, in the binary search tree, everything on the right side is basically greater, right? Every key is greater than the original key on its right side. So what happens if we get the sum of all the keys on the right side of it? Okay, so here all the keys, these are the keys. So 5, so see here, it is 5 plus 6 plus 7 plus 8. Okay, so this sum plus the sum of itself, okay, that we have to replace basically. Okay, so this will become what? 5 plus 6, 11, and 15. 11 plus 15, it becomes 20. Yeah, it becomes 26. Okay, so this 26 plus 4. Okay, so 26 plus 4 equal to 30. So basically we have to replace 4 with the 30. So everything coming from right side plus key itself. Okay, so same thing we have to repeat everywhere. Now after completing this guy, root guy, we have to call same function on left side as well as right side. Okay, so this is a recursive approach, but this recursive approach would be our bottom up approach. Okay, so we will call it in bottom up approach manner. We are not going in top down, otherwise it will take time complexity would be higher. So let me write the code of it, that what would be our bottom up approach. So see here, and also one more thing is, it's not only about the right child of it, but see here, take an example of this node 1. Okay, so right child, everything which is right side, that is also greater than whatever node it is, plus if it is not the root node, that means anything which is coming from parental side. See, all these node for this one, all these node would be also greater. So we have to take care of this condition as well. So basically we have to replace with all the child, all the right child elements sum plus everything which is on the top of it. Okay, so we have to take care of all these things. So let me now write the code of it. So see here, I have written, this is my code. I have written one utility function. Okay, so what I am doing here is, I am taking root and plus I am passing an integer array. Okay, I'll tell you why integer array. Okay, because I am using Java. So for Java, this is only one integer of size 1 only, integer array of size 1 only. But because it's a Java and Java is pass by value. Okay, so for that reason I'm basically passing as an object. Otherwise in other language this could be just a integer x. Okay, so for that reason I'm just passing an object. So now what I'm doing here, first of all I'm checking if there, that is a leaf node only, so root doesn't have any left or right child. That means we are making this r0 equal to r0 plus root val, and then root dot val equal to r0. Okay, whatever value we have, and we are returning. Now you might have that, why to do this thing, because we are doing the further calls, right? So to do the further calls, this would be useful. Let's say we are calling on the right side, when there would be a condition, when this condition would be matched, then we have to park the sum of all the values here. Okay, that is why this r0 I am taking and making the plus. Okay, plus of all the values, plus the whatever value it already have. Now see here, first of all we will check if right child is not null, then we are calling this guy util root right r. Okay, we are calling this function recursively. Now see here, when we will come out of this function, we have to check that r0 is equal to r0 plus root dot val. Okay, because this is the root. Okay, so for this root we have called, okay, this left child. So we have to do is r0 is equal to r0 plus root dot val, and then we have to assign this root dot val equal to r of 0. Okay, and with similar values, if we are checking if there is no if this left child is also available there, Then we are calling the util root dot left and air. So all the values so far we have parked in air is also being passed here, because in the left side everything would be greater, right? Whatever value in air already have, so till root and the right side of root everything would be greater, so we are passing all those value again here. Okay, and similarly this function will recursively call accordingly, and then we are at the end we would be updating everything. So think it as a recursive way. Okay, so whenever we are calling here, this all definition would be taken care. Okay, so you can consider wherever a util function is being called, think about the entire function, how it is working, so it will work accordingly for each and every further node. And then that is why we are calling it bottom up approach. Okay, so then after doing this, we are calling this function here. See here, I'm creating one size array with a 0 initial value, and then I'm calling this util function, and finally after util would be update everything, and then we have to return the root itself. Root is not changing at all, only the values are changing. So let me run this code. And yeah, it is working fine. Let me submit it. Yeah, so this is 100% faster. So thank you for watching the video.